The man who saw the invisible, how James Clerk Maxwell quietly built the modern world. In 1864, long before smartphones, satellites, Wi-Fi, or even radio existed, a quiet Scottish physicist sat at his desk and wrote down a set of equations. There were no glowing machines around him, no dramatic inventions buzzing with life, just paper, ink, and thought. Yet those equations would one day allow humanity to send voices through the air, stream videos across continents, and connect billions of people through invisible signals. The physicist's name was James Clerk Maxwell. You may not hear his name as often as Edison or Tesla. But if you are reading this on a screen, using wireless technology, or living in a connected world, then you are already living inside Maxwell's legacy. And the most astonishing part? He never saw any of it. A quiet mind with endless questions. As a child in Scotland, Maxwell was endlessly curious. He wanted to understand how everything worked: doors, wires, streams, light. He would constantly ask, "Show me how it does." At school, he didn't fit in. Other children mocked him and called him strange. But while they laughed, Maxwell was quietly exploring geometry and writing scientific ideas. Far beyond his years. By 14, he had already published his first paper. He was not loud, not flashy, but he saw patterns others could not. Yet there was something else about Maxwell that set him apart. He was not a harsh or combative genius. While many great scientists of his era were known for rivalry and ego, Maxwell was remembered as kind, warm, and quietly joyful. He wrote playful poetry. He sang songs. He was deeply devoted to his wife, Catherine, who often worked alongside him in his experiments. In a world of intense personalities, Maxwell was something rare. A gentle genius. Which makes it all the more surprising that the same mind imagined one of physics' most mischievous ideas, Maxwell's demon. The invisible revolution. From forces to fields. To understand Maxwell's genius, we need to step into the scientific world before him. In the early 1800s, scientists believed forces worked almost like magic. If two objects attracted each other, the force seemed to act instantly across empty space. No explanation, no medium, just action at a distance. Then came Michael Faraday, who imagined something different: invisible fields filling space. Maxwell took Faraday's intuition and turned it into mathematics, and in doing so, he reshaped reality itself. He showed that space is not empty. Instead, it is filled with fields, regions where energy exists, stretches, and moves. Not a void, but a living structure. Today, physicists describe the universe not as solid objects floating in emptiness, but as a vast, shimmering sea of overlapping fields, electric, magnetic, gravitational, all interacting constantly. What we call empty space is actually alive with invisible activity. This was one of the greatest shifts in human thought since Newton. Maxwell didn't just solve a problem. He changed how we imagine the universe. The moment of genius, when beauty became truth. Maxwell's greatest breakthrough did not come from an experiment. It came from a feeling. He was studying the known laws of electricity and magnetism, trying to combine them into one system. But something bothered him. The equations were incomplete, unbalanced, not elegant. So Maxwell made a bold move. He added a new term, something no one had measured yet, simply because the mathematics demanded symmetry. He called it the displacement current. And suddenly, everything changed. The equations began to predict waves, ripples moving through space itself. Maxwell followed the math further and made a calculation. He discovered that the speed of these waves depended on two known constants. One from electricity and one from magnetism. And when he combined them, he found, it matched the speed of light. Exactly. That was the moment. Light was not separate from electricity and magnetism. Light was an electromagnetic wave. In one quiet realization, Maxwell unified three mysteries of nature into one. It was one of the most beautiful discoveries in the history of science. From thought to reality, the birth of wireless. At first, Maxwell's ideas were too abstract for many people to grasp. They were just equations. But years later, a scientist named Heinrich Hertz decided to test them. He built an experiment using sparks and coils, and to his surprise, invisible waves appeared exactly as Maxwell predicted. The waves were real. Soon after, Guglielmo Marconi used those waves to send signals across the Atlantic Ocean. The age of wireless communication had begun. From that moment, the world changed rapidly. Radio, television, satellites, Wi-Fi, Bluetooth. Every message sent through the air today traces back to Maxwell's insight. He didn't build the devices, but he made them possible. The demon and the birth of information. Maxwell's imagination did not stop at electromagnetism. In 1867, he proposed a strange idea now known as Maxwell's demon. Imagine a tiny being controlling a door between two chambers of gas, sorting fast and slow molecules to create order from disorder. At first, it seemed to break the laws of physics. But over time, scientists discovered something deeper. To sort molecules, the demon must gather and erase information, and that process has a cost. Erasing information produces heat. That insight changed everything. It revealed that information is physical. Not just abstract data, but something tied to energy and reality itself. Today, this principle governs modern computing. Every processor, every data center, every device must deal with the heat generated by handling information. In a strange way, Maxwell's imaginary demon helped lay the foundation for the digital age. The color of light, seeing the world in three parts. There is another side of Maxwell's genius that feels almost poetic. In 1861, he conducted an experiment with a simple object, a tartan ribbon. He photographed it 3 times, through red, green, and blue filters. Then he projected those images together. The result was the first color photograph in history. Maxwell had discovered that all colors could be created by combining 3 primary components, red, green, and blue. Today, every screen you look at uses this exact principle. Each pixel is made of tiny red, green, and blue lights blending together. Which means that even now, as you read these words, you are seeing the world through Maxwell's idea. His work is not just around you. It is literally how you see. A mind that saw beyond its time. Maxwell's brilliance extended even further. When scientists were puzzled by Saturn's rings, he used mathematics to prove they must be made of countless tiny particles, not solid structures. More than a century later, spacecraft confirmed he was right. Again and again, Maxwell saw truths long before technology could verify them. He trusted that nature had hidden order, and that mathematics could reveal it. The invisible legacy. Decades after Maxwell's death, another revolutionary physicist would fully grasp the depth of his work. When Albert Einstein was once told that he stood on the shoulders of Isaac Newton, he reportedly replied, "No, I stand on Maxwell's shoulders." Einstein even kept a framed portrait of Maxwell on his study wall, a quiet tribute from one genius to another. It was Maxwell's equations that helped inspire Einstein's theory of relativity and reshape our understanding of space and time. James Clerk Maxwell died in 1879 at the age of 48. He never saw radio, never saw television, never saw the internet, yet his ideas made all of them possible. Today, his work is everywhere, so deeply embedded in modern life that we barely notice it. The signals in the air, the colors on your screen, the flow of information in your devices, all of it traces back to a quiet man who believed that the universe could be understood through patterns, symmetry, and thought. Maxwell did not just write equations. He revealed an invisible world. And in doing so, he quietly built the one we live in now.
It's time to study new words in context. 1. Equations. Definition. Equations are math sentences that show two things are equal. Example: the teacher wrote equations on the board to solve the problem. 2. Dues. Definition. Do's means does in a Scottish way of speaking. Example, the boy asked, "How does this machine work?" But he said, "How does it work?" 3. Flashy. Definition, flashy means very bright, showy, or trying to get attention. Example, he wore a flashy jacket that everyone noticed. 4. Combative. Definition, combative means ready to argue or fight with others. Example, the student was combative and argued with the teacher often. 5. Mischievous. Definition, mischievous means playful but a little naughty or causing small trouble. Example, the mischievous cat knocked the glass off the table. 6. Shimmering. Definition, shimmering means shining with a soft, moving light. Example, the water was shimmering under the sunlight. 7. Symmetry. Definition, symmetry means something is balanced and looks the same on both sides. Example, a butterfly's wings show symmetry because both sides match. 8. Electromagnetic. Definition, electromagnetic means related to electricity and magnetism working together. Example, light is an electromagnetic wave that travels through space. 9. Grasp. Definition, grasp means to understand something clearly. Example, it took time for her to grasp the new idea. 10. A tartan ribbon. Definition, a tartan ribbon is a strip of cloth with a pattern of colored squares and lines, often from Scotland. Example, she wore a tartan ribbon in her hair with red and green patterns.
Comprehension questions. 1. Who was James Clerk Maxwell? Answer. He was a Scottish scientist who helped explain electricity, magnetism, and light. 2. What did Maxwell write in 1864? Answer. He wrote a set of equations that explained how electricity and magnetism work together. 3. Why is Maxwell important to modern technology? Answer. His ideas made wireless communication like radio, Wi-Fi, and smartphones possible. 4. What kind of child was Maxwell? Answer. He was very curious and always asked how things worked. 5. Why did other children call Maxwell strange? Answer. Because he behaved differently and focused deeply on learning instead of playing. 6. What does a gentle genius mean in the article? Answer. It means he was very smart, but also kind and not aggressive. 7. What did scientists believe about forces before Maxwell? Answer. They believed forces acted instantly across empty space like magic. 8. What idea did Michael Faraday introduce? Answer. He introduced the idea of invisible fields filling space. 9. What did Maxwell prove about space? Answer. He proved that space is not empty, but filled with energy and fields. 10. What problem did Maxwell see in the old equations? Answer. He saw that they were incomplete and not balanced. 11. What is the displacement current? Answer. It is a term Maxwell added to make the equations complete and correct. 12. What important discovery did Maxwell make about light? Answer. He discovered that light is an electromagnetic wave. 13. Who proved Maxwell's theory with experiments? Answer. Heinrich Hertz proved it by creating electromagnetic waves. 14. What is Maxwell's demon? Answer. It is a thought experiment about a tiny being that sorts molecules and challenges physics laws. 15. What did Maxwell discover about color? Answer. He discovered that all colors can be made using red, green, and blue. 16. What did Maxwell predict about Saturn's rings? Answer. He predicted they are made of many small particles, not a solid ring. 17. What did Einstein say about Maxwell? Answer. He said he stood on Maxwell's shoulders, showing Maxwell's great importance. 18. Why didn't Maxwell see the impact of his work? Answer. Because he died before technologies like radio and the internet were invented.